few more definitions. Now let's look at what a unit vector is. Sounds, probably the name of it implies what it is. A unit vector is a vector of size 1, whose magnitude is 1. All right. Now often these vectors are used to indicate the direction a vector is going in. Okay. Now a unit vector, it's got a little symbol on top, and it's actually a hat. It is a hat symbol, and actually we call a unit vector a hat. Okay, so it's bolded. The magnitude out the size of the magnitude of a unit vector by definition is 1, which means it's a vector divided by its magnitude. That makes any unit vector, that makes any vector a unit vector. All right. So we define 3 significant unit vectors in vector space. Okay. So the 3 unit vectors that are defined universally are the I, J, and K vectors. So unit vector I is a vector of length 1 in the direction of the x-axis. The unit vector J is a vector of length 1 in the y direction. And then a unit vector K, okay, is a unit vector, strangely enough, in the direction of the z-axis. So in 2 dimensions, okay, I is equal to 1, 0, 1 in the x, 0 in the y, j, 0 in the x, 1 in the y, and then obviously a 3-dimensional vector, 1, 0, 0, 0, 1, 0, 0, 0, 1. All right. So we often use these 3 vectors to describe a vector on the Cartesian system. So we use I, J, and K. So for example, we've got the vector P here, 2I plus J plus 3K. So it's 2 along the X, 1 along the Y, 3 along the Z. All right. So the point 2, 1, 3 is written as the vector P, 2I plus J plus 3K. So OA, 1 plus 2 plus 3, 1 in the X, 2 in the Y, 3 in the Z. All right, so again, the magnitude of our vector is the square root of each of the individual terms squared. So if it's 2-dimension, x squared plus y squared, 3-dimension, x squared plus y squared plus z squared. All right. So now this is all about terminology, really. All right, the vector 6i minus 3j plus ak has a magnitude of 8 units. All right, find the value of A. All right, so first things first, the magnitude of our vector, we'll just put 6i minus 3j plus ak. The magnitude of that is equal to the square root of 6 squared plus negative 3 squared plus a squared, and that has to equal 8. So if I square both sides now, actually I'll do that in a minute. So I've got 36 plus 9 plus a squared is equal to 8. Square both sides, I get 45 plus a squared is equal to 64. Subtract a squared is equal to 19, I hope. Therefore, a is equal to plus or minus the square root of 19. A is an element of R, so it can be positive or negative. All right, so first things first, the magnitude, square root of each of the components squared, and then a little bit of algebra. Okay, so the vector points P and Q are given, respectively. Then the magnitude of PQ is. So this is where it's really important. That P and Q, what we're saying there is we're saying relative to some point, and I guess without trying to sketch too much where we're going, so 1, 1, negative 1, I don't know, it's hard to draw a point in 3 dimensions in a 2-dimensional place. So maybe that's the point P there, yeah, relative to the origin O. And that's the point I wanted to make here. So OP is equal to I minus J minus 2K. And in the same way, OQ is equal to minus 2K. So we've got some point. So roughly, let's try and sketch it. 2 in the X, 1 in the Y, minus 2K. So it's down here somewhere maybe. And there's the vector P to Q there. That's the one we're looking for. All right. So what is the vector PQ? PQ is equal to PO plus OQ, which is OQ minus OP. Yeah, because that's the PO is the negative of OP. So that's equal to OQ, which is here. So that's equal to 2 minus 1I plus 1 minus negative 1J plus minus 2 minus minus 2K, which is equal to I plus 2J plus 0K. So that's what PQ is. The magnitude of PQ is equal to the square root of 1 squared plus 2 squared, which is root 5. All right, there's a bit there. Let's keep working through it. A is the point, B is the point. Express the position vectors of A and B in terms of. So again, it's that OA, OB. So every opportunity, when you get given a point and it just says A or P or B or M, write OA or OB or OM, okay? OA is equal to minus I plus 3J plus 4K. OB is equal to 2I plus 4J minus K. Okay, we've done that. Express AB in terms of I, J, and K, so it's the same sort of thing. AB, AA plus OB, which is OB minus OA, which is, sort of do it in our head a bit now, B minus A, 2 minus minus 1, which is 3I, 4 minus 3, which is J, minus 1 minus 4, minus 5J. So there's my vector AB, and hence determine the length of AB. So the magnitude of AB is equal to the square root of 3 squared plus 1 squared plus negative 5 squared. Obviously, we're squaring everything, so the negatives will always disappear. 9 plus 1 plus 25, isn't it? Which is equal to square root of 35. So there's our magnitude. All right, so that vector, that's the length of that vector. All right, so which of the following vectors has a magnitude of 7? Okay, so what we need to do is just, we can be a bit intuitive about it and make decisions upon what reasonable. The magnitude is the square root of each of the individual components squared. So C, 7 squared plus 7 squared plus 7 squared is not going to add up to 49, is it? So we need the square root of 49 as the answer. So we can quick mental check of 2. 2 squared plus 6 squared plus 1 squared. Probably not. Let's check A. 4 squared plus 5 squared, 2 root 2 squared. 4 times 2 is 8. And there's our 49. So there's our magnitude there. So really it's just an exercise in guessing and checking really. And therefore, the magnitude of 4i plus 5j plus 2 root 2k is in fact 7, which is what we needed to do. Bottom one, 16 plus 9 plus 25. Not quite, square root of 50, close, but no cigar. So, it really is for some multiple choice, you've just got to check every response, but you can be a little bit intuitive about it. Example 6, we can see that OA is equal to 2i minus 3j, OB, I plus 4j, and OC minus I minus 3j. So it helps to define each of the vectors you've got. So we've already got OA there, so that's nice. Now we need AB. So the vector AB is AO plus OB, which in turn is OB minus OA, isn't it? So then we can just subtract them as we go. So 1 minus 2 is negative I. 4 minus 3 is 4 plus 3, so it's plus 7j. So there's vector AB. Do something similar for BC, which is OC minus OB, which is OC minus OB. So it's these two vectors. So minus I is minus 2I. And what have we got? OB. OC, sorry. Minus 3 minus 4 is minus 7. Minus 7j, so there's vector BC. All right. Find the point F such that OF is equal to a half OA. Well, a half OA is equal to a half of 2I minus 3j, which is equal to I minus 3 on 2j, which is what OF is equal to. And finally, find this G such that AG is a half BC. So we've got BC there somewhere, I think. Yep. So a third BC is equal to negative 2 on 3I minus 7 on 3j. And then we're saying that AG, which is AO plus OG, has to equal negative 2/3 I minus 7 on 3j. So we need the point G. So we need OG is equal to, so 2/3 I minus 7 on 2j. So I want to subtract AO from both sides, which means in the end I'm going to add OA. Yeah, negative AO is OA. So therefore OG is equal to 2/3 plus 2. So that's 8 on 3I. And negative 7 on 2 plus negative 6 on 2, negative 13 on 2j. So that's our point OG. All right, next example. So we've got two vectors, A and B. Find M the midpoint of AB. So we'll just approach it slightly differently. AB is in fact AO plus OB, OB minus OA. So it is reasonable. We might just do the vector sum. So it's OB minus OA. So 5 minus 2, which is 3. 1 minus 4, which is 5. 7 minus 5, which is 2. So there's the vector AB. M is the midpoint, so it's halfway. So there's A to B, and there's M there. Yeah, that's the midpoint, so that's halfway. So AM is equal to a half AB, which is equal to 3 on 2, 5 on 2, 1 as a vector. So that's the point AM. So AM itself, so we want the point OM, don't we? So because I need the point M. So therefore OM is equal from O to A plus A to M, which is OA, which is 2, negative 4, 5, plus AM, which is 3 on 2, 5 on 2, 1. So if I add those two vectors together, I get 7 on 2, negative 4, so negative 8 plus 5 is negative negative 8 plus 5 is negative 3 on 2. 5 plus 1 is 6. So there's my vector OM. So if you like, in vector form, 3 on 2j plus 6k.